Hey everybody, thanks for clicking on this video. Today we're going to be working with the sine, sum, and difference identity. If you want to follow along, the links to the companion worksheet are in the description below. Also, don't forget to click that subscribe button so you can stay up to date on all the videos that we have coming out from the channel. So let's get started. So with the sine, sum, and difference identity, if we're adding two angles or subtracting two angles, we don't just add the sine of those two angles together. It's a little bit more complicated than that. We take sine of the first angle times cosine of the second angle, plus or minus, depending on what we're doing, sine of the second angle times cosine of the first angle. So looking at number 1, we want to find the sine of 15 degrees. Now unfortunately 15 degrees doesn't show up on the unit circle. So what we do is we have to say, how do we get 15 degrees from the angles that do exist on the unit circle? Well, we can take 60 degrees and subtract 45 degrees, and that would give us 15. So following the rule that we have here, we're going to take sine of the first angle, that's 60, times cosine of the second angle, that's 45. And these two we're multiplying. But then what we're going to do is we're going to subtract, because we see plus or minus, plus or minus. So if we're subtracting here, we're also going to subtract there. So then we take sine of the second angle, which is 45 degrees, times cosine of the first angle, which is 60 degrees. Now all four of these we can find from the unit circle, and I've put a link in the description below if you need to refer to the unit circle. So sine of 60, that is square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. Sine of 45 degrees is square root of 2 over 2. Cosine of 60 degrees is 1/2. So now we have these two fractions and these two fractions, and we're going to multiply. So square root of 3 times square root of 2 is square root of 6, all over 2 times 2, which is 4. So over here, we have square root of 2 times 1, which is square root of 2 over 4. Now, since these two fractions have the same denominator, we can combine them. Square root of 6 minus square root of 2 all over 4. So there's our value in exact form. Now with the second one, here we want to find cosecant of 105. Now we don't have a sum difference identity for cosecant, but what we recognize is that cosecant is just 1 over sine of 105 degrees. So if we can find sine of 105, then we just take the reciprocal. So what is sine of 105? Well, 105 isn't on the unit circle, but if we look at two angles that are on the unit circle, we can add them together. And that's going to be 60 and 45. Now, if you notice, this setup is almost identical to here. The only difference is here we subtracted, over here we're adding. So that means we can save ourselves a little bit of time, because there's no point in writing out all the same work a second time. And that is, if the only difference is that we're adding instead of subtracting, then we might as well just jump down to the answer and say, well, this is going to equal square root of 6 plus square root of 2 all over 4. But this is sine of 105. We want cosecant of 105. So for that, we're going to have to say cosecant of 105, that equals 4 over square root of 6 plus square root of 2. Now, if your homework or your teacher insists on rationalizing this denominator, we can do that. We're going to multiply square root of 6 minus square root of 2 all over square root of 6 minus square root of 2. So the 4 is going to distribute on the top. So we have 4 times square root of 6 minus 4 times square root of 2. Now on the bottom, we have to treat these as two quantities. So we have to multiply them the way we would multiply binomials. So square root of 6 times square root of 6 is 6. Square root of 6 times negative square root of 2 is negative square root of 12. Square root of 2 times square root of 6 is plus square root of 12. Square root of 2 times negative square root of 2 is minus 2. Now we can't combine like terms on the top, so we're left with 4 square root of 6 minus 4 square root of 2. But the radical 12s, they cancel. And so we have 6 minus 2, which is 4. So that means the 4's here, here, and here cancel. And so we're left with radical 6 minus radical 2. So that's the exact value of cosecant of 105. We found sine of 105 and took the reciprocal. Now on the second page, we have a problem that's a little different than what we had on the first page. We want to find the value of sine of x minus y. They tell us that sine of x is 4/5 and secant of y is negative 25 over 7. So what we do is, we don't know what angle x is, we don't know what angle y is, but we do have enough information to draw a picture. They tell us that x is between 0 and 2 and pi over 2. So that means it's somewhere in the first quadrant. And we know that sine is 4/5. So we can say the opposite side of this right triangle is 4, and the hypotenuse is 5. And so using Pythagorean theorem, the adjacent side of this reference triangle, because this angle is x, this is 3. Now for y, they give us that secant of y is negative 25 over 7. But let's think of this as cosine, the reciprocal. That's negative 7 over 25. Now, y is in the second quadrant. But if we draw a reference triangle over here, cosine, the adjacent side is negative 7, the hypotenuse is 25, and using Pythagorean theorem, the adjacent side is 24. So with this information now, we can figure out what this is. Because we don't know what x is, we don't know what y is, but we can apply the sum difference identity. And so this is going to be sine of x cosine of y minus sine of y cosine of x. Now all four of these we can find from our picture that we drew up here. So what is sine of x? Well, that's opposite over hypotenuse. They gave us that. 4/5. Cosine of y, well, they gave us that indirectly. That is negative 7 over 25 minus. Now what about sine of y? Well, that's the opposite, 24 over the hypotenuse, 25. And then what about cosine? Well, that's the adjacent side, 3 over the hypotenuse of 5. So let's multiply these. So 4 times negative 7 is negative 28 over 125. 24 times 3, that should be 72 over 125. And thankfully we have a common denominator here. So when we subtract them, that's going to give us negative 100 over 125. And we can actually say that this is, well, let's see, this is negative 4 times 25, and this is 5 times 25. So that means, if we did this right, we should be left with negative 4/5. Now, the last one is we want to prove this identity, and this is called the cofunction identity. Whereas these two angles are complementary. If we added them together, they'd add up to pi over 2, or 90 degrees. Now the way we can prove this is, well, we're subtracting two things, pi over 2 minus x. So what does the sum difference identity say here? Well, we should take sine of pi over 2 times cosine of x minus sine of x times cosine of pi over 2. Now x we still don't know, but we can find sine of x, sine of pi over 2, and cosine of pi over 2. And sine of pi over 2 is going to be 1 times cosine of x. And cosine of pi over 2 is going to be 0. So since we're multiplying by 0, this term disappears, and we're left with just 1 times cosine of x, which is just cosine of x. So by applying the sum difference identity and treating this pi over 2 and this x as two separate angles instead of one quantity, we show that yes, indeed, sine of pi over 2 minus x does equal cosine of x. So you can always use this, and there's a whole lot of identities that involve adding or subtracting two things inside of sine or cosine or any of the other trig functions. And this is one way we use to prove that to be true. Thanks for watching. If you like the video, please give it a thumbs up. You have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.